Cool. All right. So my first announcement is that lesson 6 online homework is due Friday by midnight, and the worksheet number 4, that medical testing sheet, is also due by class time on Friday. So other announcements and comments that I'd like to make is that we will be most likely wrapping up lesson 7 today. I really just need to work through some more examples. And then your next class activity, I was actually going to either hand out on Friday or the following Monday. And it's going to involve lesson 6 and lesson 7 combined. Yeah, sure. Absolutely, Tara. Thanks for asking. I'm sure other people will appreciate you doing that too. I'm happy to go through that. Yeah, are things going okay for all of you? Ish? Okay. Well, are you psyched for tomorrow that it's like the one day you don't have math? No. Okay. Well, hey, and let's talk at the end of class so we can figure out a good time. So along that line, I want to say that I am happy to meet with you all. I love helping students one-on-one, or if there's a group of you together. I just need you to email me your available days and times, over the next several days, and then I can find us mutually convenient one. I teach a bunch of classes, and I'm on a lot of university committees that have meetings that kind of bebop from week to week. And so we can always find time. It just is particular to the week. So please never hesitate to reach out to me so that we can find a meeting time. I just really want to emphasize that. I mean, evenings can work, afternoons, and some mornings as well. It just, for me, it really depends upon the day. And then also I need to meet whatever your schedule is as well. So before I jump into the rest of, I thought for sure I brought my reading glasses down. Not just behind. There they are. Okay. Before I jump into the rest of lesson 7, there was a request for Tara, did you want number 1C? Was that what your question was? Yeah, okay. So there's a question on this worksheet on number 1C. So if you haven't picked up a copy of it, I have copies here today. There's copies on Moodle as well. So please do be sure that you get that so you can hand it in Friday in class. Again, the reason for this worksheet is not to, it's actually easier than you think it is, I promise you. And people are so used to math, like looking to find the hard part. But the whole point of this assignment was so that you could see that this conditional probability is actually used all the time, like in the quote unquote real world, in the practical world. Okay, so just a bit of background on this. This one has to do with medical testing, and obviously the nature of the errors that exist within medical testing. No test is perfect, quite clearly. So what we're dealing with in number 1 is I'm defining what the sensitivity of a medical test means, and then you're actually computing it using this two-way table. Okay, So it says the sensitivity of a medical test is the probability the test is positive when it should be positive. In other words, how sensitive literally is the test to picking up on those antibodies. Okay. And so what we want to do is we want to compute the sensitivity of the test that we see right here. And the reason why I'm talking about all of this and not just jumping to part C is because parts A and B give you the answer to C. Okay, so part A and part B really are just reading the table. How many patients have a strep infection? Well, here are the sore throat patients with strep. What's the total of number of patients with a strep infection? 120, right here, right? Now we want to know of the patients with a strep infection, how many received a positive test? Well, here's our strep infection people. We have 96 with a positive test and 24 with a negative test. What were we looking for here? 96. So if a patient has a strep infection, notice our use of the conditional word if. We're reducing our sample space down to the people who have strep. That's 120. What is the probability that the test will correctly diagnose the patient with a positive result? It's just 96 over 120. Yeah. I mean, if you want to divide it and get a decimal, cool. If you want to change it to percent form, cool. If you're kind of like the Lauren style person, you'd be like, done. Yes. Wasn't that a little anticlimactic?
So like on the first part, you don't have to put like 120 or 500. You put 120.
120, because notice I'm only asking how many. I'm not asking to find the probability. Does that help? Okay, and notice in part B, I'm just asking how many. On number one, if you wrote it as 1200 over, no, that's not correct. Because number one, here I'm just asking how many people. If you put 120 over 500, you're finding the percentage of people or the probability, and we're just asking how many. Maddie, does that answer your question? Cool, cool. Yeah, it's really, really important that you answer the question that's being asked. So if it's just how many, I'm just asking you to read the table. Any other questions on this worksheet? Number 2C. There's oh, 2C. Yeah, thank you. Okay. So let's look at number 2. Now I'm gonna have to, good thing I have extras. So now we're talking about the specificity of a medical test. So that's the probability that the test is negative when it should be negative. Okay. In other words, the sensitivity is, does it pick up those particular antibodies? And the specificity is essentially, does it distinguish those antibodies from the other, illnesses that other people might have? Okay. So how many patients here do not have a strep infection? Well, here's sore throat patients with other causes or infections. How many is that? 380. How many of these patients who do not have a strep infection got a negative test? 361, good. So part C is if a patient does not have the strep infection. In other words, we're reducing our sample space down to all those patients who don't have a strep infection. What is the probability that the test will be negative? Well, that's 361 over 380. Riley, is that okay? Cool. So is this looking a little easier than what you had thought it was going to be? All right. Any other questions on this? We can talk 3 and 4 too, if you want to. You're okay with 3 and 4? Okay, there's a question to do 3. Riley, the class is going to love you and appreciate you asking these questions. Cool. Okay, so now what we want to talk about are false negatives. And you know, when it comes to medical tests, I don't really know which is worse, a false positive or a false negative. Okay, so when we talk about false negatives, it means that your test came up negative when you really have the disease. Okay, that can be bad if it's a really bad disease that's really transmittable, because then you don't know you have it and you're giving it to everybody else. Okay, that's the bummer about the false negatives. Okay, on the other hand, false positives can cause quite a scare, because a false positive means your test came out positive even though you don't have the disease. So here you got tested for something you were totally scared to have, and it came out positive, but it's not correct. So there's all this worry and the stress that goes behind it. Okay, so in number 3, we want to think about the patients with a strep infection who received a negative test result. These test results are false negatives because their test result was negative even though they have strep. Okay, so again, this is a matter of reading the table. How many false negatives appear in the table? Remember, a false negative is when you have a negative test result, but you actually have the disease. So these people got a negative test result from strep, but they should have because they don't have strep. So I claim it's these 24 people in the table who have that false negative result, right? Because they got a negative test result, but they got strep. You with me there? So in a similar manner, if we want to talk about false positives in the table, well, these are people who don't have strep, but they got a positive test result. How many people got a positive test result when they should not have gotten a positive test result? These 19. Right? Because they had a positive test result for strep, but they don't have strep. Okay, so going back to Riley's question, it says a patient receives a negative test result on the test for strep. How many total people got a negative test result? Ooh, well, negative test result, good job. 385 people had a negative test result. Okay, we want to find the probability that it's a false negative. Well, of these 385 people who got negative test results, How many of them were false? 24. Riley, does that help? Cool. And then just to finish off life, well, on this worksheet, notice here, we have a total of 115 people who got a positive test result, okay? Of those 115 people who got a positive test result, notice that 96 of them should have gotten that positive test result because they have strep. 19 of them should not have. So notice here with this last question, a patient receives a positive result on the test for strep. A total of 115 people had that. Again, with this conditional probability, you reduce your sample space. Of those 115 people, how many were false? 19. And there's your worksheet. Ta-ta-ta-ta. I don't know. All right, so what was the point of this? The point of this was, I want you to see that what we're studying here actually is real and really matters and has consequences, okay? Like, you know, what we talk about in here with the conditional probability and things with medical testing, it's a very real thing. And I just like, you know, so often you learn things in math and it's like, okay, well, that's abstract nonsense. Why am I learning that? You know, here you go. Here's a real direct application. Okay. And it also helps you solidify your skills in reading two-way tables. That's the other goal. Y'all okay? All right. And so, ooh, I know what I need to do. I need to exit my full screen. Jackson, absolutely. I'm so happy to help you all. I mean, at some point, you're all going to really catch on to what I'm about. Like, ask me questions. I'm so happy to answer questions. All y'all have to do is ask, right? To me, what matters is your learning, you know, whether or not you got extra help with me or the tutoring center. I just want you to learn and understand these things. So. All right, so I'm going to now share my screen. There we go. So I am looking at the lesson 7 online homework because the last couple of examples that I want to go through, I'm just going to pick some homework questions. There's just not a lot of variety in the binomial questions that can be asked. Okay. So I just want to point out a couple of things real quick with your online homework. Notice this, and I'm not going to go into too much detail on this, but you know, here you're given the probability that the voters prefer candidate A, and we want to find the probability exactly 4 of them do out of the 8 people chosen. So the quick comment I want to make here is N is 8. That's the total number of people. P is 0.35. And your X value is exactly 4. Notice since it's exactly 4, we use the binomial PDF. Don't get tripped up on question number 2. It's don't think too hard, okay? The whole notion of question number 2, and I'm not going to say too much more about it, is what does it mean to be a binomial experiment? Does the probability change from trial to trial? No, because they're independent events, okay? So by the nature, so it's like flipping a coin or rolling a die, any of that. The probability does not change from trial to trial, okay? That's what it means for them to be independent. But what I really want to head over to is question number 8. Just because it's so darn long. Okay? Y'all ready? Cool. Okay, so what we have here is we have a manufacturing machine, and what I'm going to do is I'm going to take notes on my paper right here, and then I'll stop sharing this screen, and then we'll just kind of go back and look at what each question asks. Okay, so a manufacturing machine has a 55% defective rate. Okay, obviously any machine that you have, like another classic example of these binomial distributions are like, you know, we have machines that fill up cereal boxes, right? Okay, and suppose they're geared to fill up cereal boxes to contain exactly 18 ounces. Is every cereal box going to have exactly 18 ounces? No, there's, you know, defective rates, right? And so it's just kind of a plus or minus thing. And we're going to get really into this with our normal distributions. But let's suppose that this manufacturing machine messes up 55% of the time. We need a new machine, don't we? Okay, if 110 items are chosen at random, okay, they ask what the random variable is. This isn't a question I'm going to ask you at this point, but it is important for us to start. And so what we want to know is we want to find, let's see, the random variable is your X value. So it's the number of randomly, of the 110 randomly selected items that are affected. When they're asking what's the random variable, they're asking what is the X value, okay? And the X value represents the number of defective items. And I guess we're calling our success to be defective. Success is a relative term, okay? So what is this 110? That's our total number. What value is that? Isn't that our N value? Like if we're doing this binomial distribution, N is the total number you're looking at. What is this 0.55? P. Any questions this far? All right, so we have N is 110, P is 0.55. And now what I'm going to do is go through probability of exactly 62, probability less than 62, probability more than 62, probability exactly 65,
No, mine looks like this.
probability at
five.
least,
Yeah,
i.e.
that's your
greater than or
five. I'm
equal
on
to
4.
65.
What is this? Your,
And
this is conditional.
hopefully
that's my
part F
test.
is the last
Oh, those are
one,
4 at.
or part I, excuse me, I can read.
Class activity.
Probability at most 65.
Are you doing conditions?
All right,
on
so
the
what
road?
I've done
What'd you get
is
on
I've
your
taken
text?
all I
Okay,
need
yeah.
from here. And I'm gonna stop sharing my screen. Okay? There we go. So let me
Lab
move to
activities.
full screen mode. All right. So here is our relevant information. This is really all we need in order to do these computations. Okay. Now I'm going to talk about some really important keywords precisely because it'll come into play on how to do, let's see, less than and more than. Okay, so we have our N and P. Those are not going to change at all throughout this entire problem, okay? So we want to find the probability that exactly 62 of these 110 items are defective, okay? So I want you to have that sheet of paper that we've been using the past couple of days in class on Monday and Tuesday so that you can identify which calculator function, okay? So if you have it with you, put it in front of you. Don't ask yourself to remember these things. Like, you don't need more stress on your brain, okay? So when we're finding exactly some number, someone tell me, what is the calculator function we use? Binomial PDF. And then no matter what your calculator looks like, you're going to be entering it in the order of, remember, this is the number of trials and this is the probability. And then we're interested in the 62. So 110, you got to put your probability in decimal form, and then 62. Notice it's PDF because it's at that point. So I showed you how to work calculators yesterday, and I'm happy to, I can bebop back and forth between the calculators if that would be helpful. But with this one that we provided to you free of charge this semester, you would hit second data, distri, go down to binomial PDF. We're just doing single. And now notice it says trials. I put in 110, hit enter. Probability is 0.55, enter. And we wanted exactly 62. And we will calculate that to get about 0.0734. You with me there? Anyone has a question, please don't be shy. Like, please let me help you. All right, well, while we're doing the exactly's, I look down here and I see there's another exactly. That's the only other place I'm going to be using this binomial PDF business. So I'm just going to jump down and do this one as well. Are there any questions why I'm using the PDF again? And the only difference is our N and P stay the same, but now we want 65 items to be defective. So I'll go back to my calculator function, binomial PDF. Notice I don't need to re-enter my N and P. I just need to re-enter X to be 65. And we get what, 0.0531. Y'all with me there? Okay. All right. I'm not going to be going in the order here because there's some things that I want to make a distinction about. But any questions this far? Okay. So we were playing with these a lot yesterday. These are a little bit different, so I'm going to do these two last. Now we want to find the probability, I'm going to even start down here, of at most 65. Okay, write this down in your notes if you need to. When you're talking at most 65, that means less than or equal to 65, right? It means 65 or less. And just to say one more thing about it, it means that we're counting the value of 65. You with me? So with our binomial computation here, we again are interested in 65 or less. Does our calculator compute this directly? Yeah, this is the binom CDF. And we would enter 110.55 and then 65. So what we're saying is we're finding the probability that there's 0 defective, 1 defective, or 2, or 3, or 4, or 5, or 6, all the way up through 65. Okay. So I'll go back to my calculator. I hit second data. I go to distri. But now I go down to binomial CDF. And we still have 110. Oh, 0.55 and 65 is still in there. Sweet. Wow, notice how much higher this probability is. But we have certainly a lot of different possibilities that are going to contribute to this. So I want to, are there questions on this? Everyone on Zoom, you all okay so far? I'm like leaning in to see if anyone has a response. Cool. Okay. So I'm going to now jump back up to less than some number. Okay. There's a difference between less than versus at most. At most means that you're counting that number. When I'm talking about less than 62, it's a strict inequality. Okay. In other words, I'm interested in counting 0 defective through 61 defective. Okay. So again, the difference between less than 62 versus even at most 62 is when you're talking at most, you're counting that value. When you're doing less than, you are not counting that value. You with me there? All right, so yeah, Sally, yes, and 62 is not less than itself. The hint sheet that I'm talking about was what I wrote down yesterday. It's not like an extra sheet of paper. It's just where I tell you how when to use the binomial CDF, binomial PDF, and then 1 minus the binomial CDF. So it should be in your notes from yesterday. Okay. So what we're going to compute here is binom, which function, PDF or CDF? CDF. We have 110.55. And what's my X value here? 61. Now, I don't really care what the answer is, and you probably don't either, but let's compute it anyway. I'll do it on this calculator so that people who have this calculator can also look at it. You have to go down a bit further, but there's binom CDF. And I put in 110.55 and then 61. And I get 0.5747. You with me there? Okay. 2 more. So which one should we do first? More than 62 or at least 65? More than 62. Okay. Doesn't really matter. We're going to do them both anyway. So thank you for an opinion. Okay. Notice here we want to find the probability that we have more than 62 defective items. We are not counting 62 when we are having more than, right? Okay, so again, the contrast between more than or at least is when you're talking at least, you're actually talking about that value. When it's more than, you're jumping. Okay, so we want to find the probability that there are more than 62. Okay, what does that mean? It means we want to find the probability that there's 63 or more defective items. Do you all agree with that? Okay. So this is where we take a deep breath and we say, well, wait a minute. Our calculator doesn't go into the more than or greater than direction. Okay. This is what we want, but the way we have to get there is using the complement. What is the complement of 63 or more? Well, if it's not 63 or more, what is it? Isn't it 62 or less? Yeah, right? The complement means everything else. Does that make sense? Okay, well, we can find this probability. That's binom CDF 110.55 62. But that's not what we want. If we want the complement, how do we find then what it is we want? Because the CDF always goes less than. Anyone remember from yesterday? Beautiful. You rock. It's 1 minus. Remember, the total probability of everything is 1, right? So whatever this probability is, plus whatever this probability is, has to be 1. So if our calculator can find that, let's compute that and then take 1 minus it. So here we go. I'll go down to binom CDF. We have 110.55, 62. And that gave us 0.6481. So my answer for what I'm that's the probability of 62 or less being defective. Now I'm just going to take 1 minus that. So my answer here is 0.3519.
Wait, isn't it 3159
All
instead of
right.
35?
Now we have at least 65. Doesn't at least 65 mean 65 or more? Okay, so again, the difference between more than some number versus at least some number is whether or not you're counting that number. Okay, so if we want to find the probability of 65 or more, what do? Well, again, our calculator doesn't do this. What does our calculator do? The less than, good. So what is the complement of 65 or more? Good job, 64 or less. So we're going to compute that using our binom CDF. And that'll tell us what the probability of less than or equal to 64 is. And then we'll take 1 minus that. Here. Right here, this is 64 because at least 65 means 65 or more. So the complement is 64 or less. Okay. And so we can do that as well. Here's binom CDF, and we have 110.55. I'm going to enter 64. And we got, 0.7779. So that's the probability that there's going to be 64 or less defective items. So then what I'll do is I'll take 1 minus that. And our answer here is 0.2221. Now, is a test going to have all of these questions? Heck no. You know, I mean, I'm not here to test you whether or not you can push buttons in a calculator. This was the beauty of being back when we had formulas and there was no calculator to use to do these things. But I want to get you geared to do the online homework. You will have to compute a few of them. I will be honest that typically on tests, you know, I'll tell you a little story. I'll ask you if it represents a binomial distribution. So you'll need to know what are the criteria to be a binomial distribution. And then I'll have you find a few probabilities. And to be perfectly honest with you, it's usually those, because that's what comes up most often. Okay, so that completes lesson 7. I will assign the homework to be due a week from today. So I hope this section was okay. I started this section by telling you it's very much a calculator section. And so, you know, have all of this in front of you so that you know which buttons to push on your calculator. Okay. I won't see you tomorrow because we don't have class tomorrow, but I'll see you Friday. And again, please know if you have questions on your online homework, on anything, all you got to do is ask. Okay. I'm happy to start out class every day by answering questions. Okay. All right. Have an awesome day, my friends.